Hello, everybody. So, as we all know, Napier lived in the 1500s. And back then, calculators didn't exist. So, all the calculations and stuff had to be done by hand. And while it's not all that bad for addition and subtraction, multiplication and division were pretty tedious. So, I'm just going to show why. Let's do some arithmetic. Some addition first. Now, as I said before, Napier was working with big numbers. So, let's get some big numbers. And this isn't going to be that bad. We all know how to add big numbers. 4 plus 3 is 7. 2 plus 8 is 10. Carry the 1. 9 plus 4. Well, 9 plus 4 is 13. 5 plus 6 is 11. 6 plus 5, 11. 8 plus 8, 16. 2 plus 3, 5. 1 plus 2, 3. And then we have all these numbers up here. We have 100. So we'll add 100 to that. We'll add 1,000, 10,000. We'll add 100,000 and 1,000,000. So we got a 4, a 2, a 2, 7, 6, 3. That wasn't very bad. That took like maybe a minute. Multiplication, different story. So I'm not even going to attempt to multiply 12 million by 23 million. I'm going to, let's say 924 plus or times 483. We truncated the numbers from before. This is going to take a long time because multiplication is distributive. We take the 4 times the 3, 2 times the 3, 9 times the 3, that's 1. Then we do the 4 times the 8, 2 times the 8, 9 times the 8, and we go to 400 as well. 400 times 4 times 20 times 900. Look at all these operations. And, for example, 4 times 3 is 12. So we have to add a 10 up here. And all these other numbers, these also have extra digits that we have to add up here. Add in this reserve up here. Like 8 times 2, that's a 16. We'd have to add 100 up there. And we have to do that for all the numbers. The reason for that is because, as we know, multiplication is distributive. 924 is the same as writing 900 plus 20 plus 4. And 483 is the same as writing 400 plus 8 plus 3. This is the same thing, even though it's a different order. Normally, we do first in, last out. 900, 400, 980, 903. We'd move on to 20, 20, 400, 20, 80, 20 times 3, and 4 times 400, 4 times 80, 4 times 3. And then we'd have a bunch of numbers down here. We'd have 900 times 400. 9 times 4 is 9, 18, 27, 36,000. We have the thousands. We'd have the hundreds. We'd have the tens, and we'd have the single digits. And we'd have to add the extra digits in reserve. And it's the same thing. Multiplication is distributive. So even though we did 900 times 3, if we reordered this, we could say 3 plus 80 plus 400 times 4 plus 20 plus 900. Up here, we did 3 times 4 first, 3 times 4, 3 times 20, 3 times 20, 3 times 900, 3 times 900. You get the picture. These are a lot of operations. More than one per column. If we counted it, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 multiplication, which is super time consuming. So Napier wanted to find a way to do multiplication problems with just addition. And that's why I started experimenting, and that's how I found logarithms. I'll explain that in a second.